Hello everyone, welcome to Mathematical Method Unit 2. Today we're going to focus on your notebook part F to find the antiderivatives, okay? Today's success criteria is I know the rules and how to apply those different rules to find antiderivatives, okay? First of all, let's recall the differentiation rule that we learned before. So we have if f of x is equal to x to the power of n, the differentiation, the derived function rule is n times x to the power of n minus 1. Okay, what we're going to do today is called anti-differentiation. So as the name, so anti-differentiation, as the name indicate, we have the differentiation rule over here on the top, and then anti-differentiation is we do opposite way. So therefore, if f dash of x is equal to x to the power of n, okay, then the original function will be equal to x to the power of n plus 1 over n plus 1 plus c. Okay, I'll talk about that today. C is the arbitrary real number. I'll talk about it a bit later, arbitrary real number. Okay. So this is the anti-differentiation rule. Okay, so we can, if you're interested, we can actually try to use differential rule to find the derived function, and you should be able to say that should be the same. Okay, so let's do this. F of x is equal to x to the power of n plus 1 over n plus 1 plus c. Okay, now what is f dash of x? What's the derived function? Back to using this by looking at over here, we know ideally the derived function will be f dash of x equal to x to the power of m. So let's apply the differentiation rule that we learned before to see whether we can actually get x to the power of m. Okay, so now over here, f of x is equal to this. Now I'm going to rewrite it. So f of x is equal to, now this n plus 1 is on the denominator, so I can move it to the front, 1 over n plus 1 times x to the power of n plus 1 plus c. Okay, this is still the original function. Now f dash of x, I start to apply the differential rule. So 1 plus n plus 1, that's what we have as a coefficient. I don't move it. Now I'm going to move that power to the front by apply the differential rule. So that will become times n plus 1 over x times x n. Okay, and then c is the constant number, the difference, and then for constant number, the differential is always 0. Okay, so will be always 0, so plus 0, and then here, so f dash of x is equal to that n plus n cancel out, and then I have x to the power of n plus 0, which is x to the power of n. So you see, so the anti-differentiation rule works. It helps us to find the original function, the derived function is to the power of n. So therefore, there is another way to write this. So initially we have f dash of x equal to x to the power of n. So this is my derived function. Now the anti-differentiation, the antiderivatives of this derived function in regards to x is equal to x to the power of x plus 1 over x to the power of n plus 1 over n plus 1 plus c. Okay, so see, as I said, this is arbitrary real number. The reason why we have this, okay, is because let's give you example. If we have a function f of x equal to x squared plus 2, if we have another function f of x equal to x to the power of 2 plus 4, okay, so then f dash of x will be equal to 2x plus 0, and then f dash of x for the one on the top will be equal to 2x plus 0 as well. And then they'll have equal to 2x, that'll be equal to 2x. So f dash of x equal to 2x, f dash of x equal to 2x. So you see here, both of these different f dash of x, original function f of x will get you the same derived function. Is because the constant number over here, 2 and 4, the constant number, different derivative of constant number is always equal to 0. So therefore, when we come backward to find the original function by using the derived function, it can be any number. It can be 2, can be 4, can be straight, and can be 100. Okay, we don't know, so therefore we have to use arbitrary real number to show, to indicate all the possible real numbers. All right. So let's back to one example. So if you check your notebook over here, so therefore I can rewrite it again. So the antiderivatives of or derived function x to the power of n in regards to x is equal to x to the power of n plus 1 over n plus 1 plus c. Okay, and then if we have a number in front of the function, we can actually move that function out, and then we can do the same thing. Okay, also if we have different functions, to find different derived function, and then to find the antiderivatives, and then we can separate them, we can do them separately. We can find the antiderivative of f of x, and we can plus, and then find the antiderivatives of g of x, and then plus c. Okay, always make sure you have that plus c, arbitrary real number. All right, so let's do one example. Find the derivatives of following. So this first one, we are trying to find antiderivative of derived function straight x to the power 4 in regards to dx. All right, so apply the rule. We can move that straight out, so they have straight, and then we have antiderivatives of x to the power 4 dx, and then now we can apply the rule. It will be x to the power 5 over 5 plus c. Okay, and then you can simplify, will be straight over 5x to the power 5 plus c. Now when you get very familiar with this, you can jump off these steps, and then you can just jump over these steps, and you can just write that's straight x to the power 5 over 5 plus c straight away. So next example, we have find the antiderivatives of x squared plus straight x minus 2 in regards to x. Okay, so we can do the opposite way, and because we have straightened function, we can separate them by using the second rule, the third rules, and then we can separate to find antiderivatives of x squared in regards to x plus antiderivative of straight x in regards to dx, and then minus the antiderivatives of 2 in regards to dx. All right, so therefore you will have equal to, by apply the anti-differentiation rule, that the first one will be equal to x to the power of 3 over 3 plus the next one is 3 times x to the power of 2 over 2, and minus, okay, if it's a constant number, so the antiderivative will be minus 2x and plus c. Okay, do not forget that arbitrary number. If you get confused about this part, how do we get negative 2x, is because let's say if we have f of x equal to 2x, I know the derived function is equal to 2. Okay, so of course when you come back, if you have f dash of x equal to 2, so the original function will be 2x. And then here arbitrary number, and then simplify, you'll have x cubed over 3 over 2x squared minus 2x plus c. Okay, now the next one, you will have antiderivative 2x x minus 4 in regards to dx. Now I'm not gonna write the detailed working out. So one little hint is, first of all, because this is the two part of function multiply together, and so therefore you need to simplify them by expanding them. So expanding them, you have 2x squared, okay, minus 8x in regards to dx. So in this way, all your function is linked by addition and subtraction. So this way, you can use the rule that we learned before to simplify, and then eventually you will get 2/3x cubed minus 4x squared plus c. Okay, same for the next one, antiderivative x plus 3 to the power of 2 in regards to dx. Now, first step, you need to expand them into x squared plus 6x plus 9, okay, because x plus 3 squared is equal to x plus 3, and x plus 3 times together, just simplify, okay, and you get that in regards to dx, and then simplify. I'll leave that to you. The next one is example F2, okay, so now find the derivatives. Okay, the question is asking you to find y in terms of x. As soon as you find that, then that means we're trying to find original function. Okay, so for the derived function, it is actually, if you're interested, for derived function is y dash in terms of x. That's derived function, which is also f dash of x. Okay, so now find the y in terms of x. Find the original function, which is anti-differentiation. Now initially we have dy by dx equal to 4x, and when x is equal to 2, y equal to 16. Okay, so dy by dx, and we know that's y dash. Okay, that's derived function. So one thing you can do is you can rewrite as in, because dy by dx is equal to 4x, so therefore dy by dx is y dash. Okay, so y dash is equal to 4x. Okay, so therefore this is a derived function. So now let's say we are trying to find derived function, so therefore antiderivatives of derived function 4x in regards to dx is equal to 4 times x to the power of 2 over 2 plus c. Always make sure you have that arbitrary number. Okay, and simplify, you will have 2x squared plus c. Okay, this is your original function. Okay, so now, which is also y. Okay, so which is also y equal to 2x squared plus c. Now here we don't know c, but we do have one number on the original function. When x is equal to 2, y equal to 12. So when x is equal to 2, y equal to 12, that is a point that on my original function is y equal to 2x squared plus c. So therefore, because so therefore you can write, because 2.2 and 16 is on the original function. So therefore you can substitute, you can substitute 16 is equal to 2 times, now here is x squared, so that will be 2 times 2 squared plus c. So 16 is equal to 2 times 4 plus c, 16 is equal to 8 plus c, c is equal to 8. So now you find the value of c, so therefore y is equal to 2x squared plus 8. That's your original function. Okay. Now let's do C. C is is giving that dy by dx is equal to kx cubed minus 4x, and that when x is equal to 2, dy by dx is equal to a, and y equal to negative 2. Find the value of y when x is equal to negative 1. Alright, so now this is my question. So here, looking at this equation, we actually have two. Let's just take all the key information over here. The question asks you to find y. So the question is asked us to find what's the y value when x is equal to negative 1. Okay, so basically we need, so this give us the hint that we need original function. We need to find the original function. Okay, but we don't have the original function. We only have the derived function dy by dx equal to kx cubed minus 4x. So therefore we can apply. So since we need this original function, so we can use anti-differentiation rule to find the original function. Okay, by applying anti-differentiation rule to find it. Okay, so now let's do that. Over here we have another information as well. When x is equal to, dy by dx is equal to 8. Okay, so when x is equal to 2, dy by dx is equal to 8, which is also y dash. Okay, and we also know when x is equal to 2, y is equal to negative 2. So therefore, when x is equal to 2, y is equal to negative 2. Okay, so this is actually 1 point on the original function. So therefore, what we can do is, you see, because dy by dx, so because dy by dx is equal to kx cubed minus 4x, so therefore again dy by dx is y dash. Okay, derived function is equal to k x cubed minus 4x. Okay, now let's apply the anti-differentiation rule to find the original function. Y dash is equal to, okay, so therefore the anti-differential derivative of the function kx cubed minus 4x is equal to in regards to dx, do not forget that in regards to dx, so therefore it will be k x4 to the power 4 over 4 minus 4x squared over 2 plus c. So simplify will be equal to k over 4 x to the power 4 minus 2x squared plus c. Okay, so this is my original function, so therefore y is equal to k over 4 x to the power 4 minus 2x cubed x squared plus c. Okay, this is my original function. Now we can use this one. Now we don't know the value of k, so to find the value of k, we also don't know the arbitrary number, so therefore we need to use the information that we got over here. Okay, so the first one we know when x is equal to 2, dy by dx is equal to 8. So what we can do is so when x is equal to 2, this is going to be so because dy by dx is equal to k to the power of cube minus 4x, okay, and also because when x is equal to 2, dy by dx is equal to 8, so therefore dy by dx is equal to 8 equal to k times 2 to the power of 3 minus 4 times 2, and then we can simplify 8 equal to 8k minus 8. Okay, so this is the first one we know, and that tells, and we also know, because when x is equal to 2, y equal to negative 2, and also because my original function is y equal to k over 4 x to the power 4 minus 2x squared plus c. Okay, by the way, you can actually solve this one out. K is equal to 2. Okay, k is equal to 2. K is equal to 2. Okay, so now let's just get rid of this one first. Okay, sorry, let me get rid of this. Now I find k equal to 2. So therefore I can put it back to my original function. So therefore y is equal to 2 over 4, because that's k, x to the power 4 minus 2x squared plus c. Okay, and then so simplify, therefore y equal to half of x to the power 4 minus 2x squared plus c. Alright, so now because when x is equal to 2, y is equal to negative 2, so now we can substitute back to this equation. So therefore when negative 2 equal to half of times x is equal to 2 now, minus 2 times 2 to the power of 2 plus c, and then negative 2 equal to 8 minus 8 plus c. So therefore c is equal to negative 2. Okay, and then because c is equal to negative 2, and so therefore the original function y is equal to half of x to the power 4 minus 2x squared minus 2. This is my function. Okay, so the question is asking you to find what is the y value. What's y value when x is equal to negative 1? So all we need to do is just apply this point when x equal to negative 1 back to the information. So therefore y is equal to half of, now x is equal to negative 1 now, so negative 1 to the power 4 minus 2 times negative 1 to the power of 2 minus 2, and then you have half of times 1 minus 2 times 1 minus 2, you have half minus 2 minus 2, that will be negative 3.5. So therefore when x equal to negative 1, y is equal to negative 3.5. Okay.